Greetings, this is Artie from Artifact Electronics. Today we're going to look at this Radio Shack TRS-80 model setup. I've started acquiring this, starting with the monitor, quite a few years ago. But when I started acquiring pieces for this, they were already going for gold prices. People were no longer giving or throwing them away. So it took me a while to get everything here at a somewhat reasonable price. The first part I got was this monitor here, which when you bought these, they came as a set. The computer, monitor, power supply for the computer, and I think cables for a cassette player. Actually, I think they also came with the cassette player. But I found this several years ago, and it is basically an RCA black and white TV with the tuner, electronics, and controls removed. The reason I bought this was the guy wrote good ad copy, and apparently had been trying to sell this for several weeks. And so he made it really cheap, threw in free shipping, and said, if nobody buys this, it's going to the landfill. And that's essentially all I had to hear. This is the connector for it, a DIN plug, 5 pins, and it takes a standard composite video input signal, but as it turns out, it also takes a 5-volt supply, and I tested it with something that output low-res composite, and it actually came up. But that was years ago. So at least one known is that the monitor does work, and if push comes to shove, I can always use the monitor that I use over there with the 8088 PC, because that one works for sure. So at least we got something to start off with. Next came the computer itself, which I got earlier this year, and this one is the upgraded level 2 model. The basic, in the original it had a 4K ROM with basic that was essentially tiny basic and pretty useless. But this one, then they came up and they upgraded these to make it more of a serious machine with a numeric keypad. The ROMs got upgraded to 12K using Microsoft Basic, and memory, which was originally 4K of DRAM, got upgraded to 16K. Now this one, I haven't been able to test it because it didn't come with a power supply. It was a don't have a power supply, can't test it deal. And I figured I could just cook one up, but it basically uses the wall power adapter, uses a transformer that has 2 center tapped secondaries. One of them is rectified, the other one isn't, and the grounds are all tied together, and it seemed like it's not as simple as just digging out an old power supply and plugging it in. So I let it sit because I didn't want to blow things up. Well, I didn't know if it worked or not, but didn't want to make it any worse until the third component came along a few weeks ago. The third component I got a few weeks ago, and that's the expansion interface over here, which it originally came with covers here, and if you covered everything up, it probably looked like a fancy monitor stand, but it actually has, as you can see, a PCB inside. And you use a straight through ribbon cable to connect the computer to this. And what this gives us is the capability to upgrade the entire system to a total of 48K, so you can put 2 rows of 16K DRAMs in here. It also has a disk controller, various expansion ports, a clock. Not really a real-time clock, it just starts ticking when you turn it on. And other than that, some of these came with serial RS-232 serial boards, which this one did not come with. And and I'll tell you why I waited this long to even power any of this up. Here's a back view of the expansion interface, and you can see it's a bit distressed. This wasn't very well taken care of, but of course what you'll immediately see, here's the main source, or the main distress I see, is that cables were just cut. Now this does, and the reason I got this and it completed everything was advertised to come with 2 power supplies. Well, power supplies may be there, but they're going to need a little bit of work. So let's have a look here. So the way this worked, here's the PCB, and they conveniently left 2 slots to put the power supplies inside, and power this off of one of the power supplies, and then power the computer off the other power supply while having the power supplies out of the way. So now if I take one of them out, as you can see, this one, the cable that supplies whatever device, computer or expansion interface, was still in here. And the reason for that is this cable was inside, directly plugged into the PCB. So it wasn't hanging outside, so they couldn't cut it. But of course the AC cable was outside and it just got chopped. And of course for this power supply, both of the cables got chopped because the cable, both the AC cord and the device cord, were chopped. So what we got to do is fix these so we can try the expansion interface, the computer, and the whole system. Of course, a quick and dirty way to solve this is we got enough of a stub left here and here, is to just put AC cords on here and a new device plug and shrink wrap it. But not for a classic computer like this. For a classic computer like this, this needs to be fixed properly with no splices on the outside. And that of course brings us yet again to the point of where we have to take apart the power supply without damaging it too much. The last time I did a power supply, I used a Dremel tool on slow setting, but it just really melts the plastic over here and makes it look really bad. I mean, you can see the ridge where it was glued together. I did some research on this, and people will just suggest the damnedest things. I mean, one guy was saying you should spray them with cold spray because that'll make the glue brittle, and then hit it with a mallet and it'll come apart. Another one said to use glue spray and then put this into like a benchtop vise and gently close the jaws on it, and it'll pop. The glue will just pop off and it'll open cleanly. Not a solution that I was very eager in trying. So I'm going to do it the old-fashioned way. The old-fashioned way is to use a hacksaw. It's not going to generate that much heat. The blade is a bit thick. It's going to take off some material, but that's inevitable. But it's not going to melt things, and all you got to do with a very steady hand, put the blade into the ridge where the top and bottom are glued together and start cutting till you know you've gotten through to the inside of this device. So once you make the starter cut and you got a straight line there, you just have to keep sawing and making sure that the blade doesn't wander till you get through. Now, one danger is always, what's behind this? How close do we have anything to the perimeter? I really don't know, so I'm going to cut very carefully until the bottom starts to separate, and then we'll see what the inside looks like, and if we can put these things back together and make them look nice. Alright, progress so far. My hands are still in one piece, and I've managed to cut a pretty straight line on the edge over here all the way around. I haven't broken through to the other side yet. I keep shining a flashlight in there to see if I'm through, but I'm not. And of course here I also found that I have to kind of cut through the strain reliefs on the same line, and there's a pretty good chance that at this point I damage the wiring itself, depending on where it is in here. Not too big of a deal since I'm going to replace the AC cord anyway, but if push comes to shove, I'll probably just shorten the wire on this one and reconnect it, if of course the blade gets close to this. Another piece of advice, and I think I've given this before: use a new blade. It'll make things so much easier for you. Alright, it's about an hour later. The first one I tried to cut open was very uncooperative, so I set it aside and I started working on this one. This one went very quickly. Look at that. We got a clean edge, and all we got to do is pull out the transformer. It's got like the rectifier board for the DC sitting on top, and also a fuse, but it's glued shut, so the fuse in here is kind of a, well, it'll protect you from the thing going up in flames, but I don't think they ever replaced the fuse itself in it. So then I turned my attention back to this guy, and finally I did the obvious. I don't know why I didn't do that at first, but pulled the rubber feet off, and there were screws underneath. Yes, I can hear all of you groaning, but the worst part was that one of the screws, as I was sawing through it, I don't know if you can see that, but I pretty much sawed off the screw head on it, and since the hole was reset, it was quite a joy to get this one out. But once I got it out, here you go. This one looks completely different on the inside. Doesn't look like I damaged anything, except this while I was removing the screw, the little plastic spacer here got separated, but I glue that back. And on this one it's different because the rectifier board isn't on here. I'm assuming that it's underneath somewhere. So let me clean up my desk a little bit, and let's have a look what happened. One of the good things was that the only good cable in here, which is the device cable, even though I fully expected to saw through it, did not get nicked or hurt, as you can see. So this one's going to stay in place, but of course we are going to use a new power cord. And that's it. So let me clean up. So I replaced the wires, and one curious thing that happened was both fuses inside the power supplies were blown. Those are slow blow half-amp fuses, and I don't know why. I replaced the fuses, I plugged in the power supplies, and under no load condition they worked fine. The computer should be fine because I didn't come with these power supplies, but I got to be careful with the expansion interface. I'm going to do some measuring around the power circuits in there before I attempt to power that up. Another thing to point out is when the plastic cases are installed, you essentially have a sealed box with no way for the heat to escape. So it's it was kind of tempting for me to drill cooling holes in there. I mean, if I wanted to do by convection, I would have to drill them on top and on the bottom. I don't want to deface these, and if I drill them on the side, that'll also deface them, maybe not as badly, but then that won't properly convection cool and you'll need a fan for it. So I'm just going to leave them the way they are. They've obviously worked for years like this. Yes, the fuses were blown, but the heat will generally not cause the fuses to blow, and if I put a new fuse in and something was hurt in there, they would have blown the fuse again. So long story short, I'm going to leave them like this. I'm going to leave them open while testing them, just in case another fuse blows or something. But I guess we're finally getting to the point where we have to do some where we can do some real equipment testing. Okay, then here we go. Monitor is plugged in. Now we'll plug in the power supply. The monitor warm up for a minute. I did do some preliminary tests on the power inputs on here, just to make sure that nothing was shorted anyway, and it seems normal, so let's go. That's a good sign. So the computer works, and obviously the power supply works along with it. And so the only thing to test is, before running anything extensive, that's actually pretty cool that it runs. Let's try that again. And let's see how much memory it sees. So it sees about 15.5K. So the 16K inside are functional, and the reason this number differs is there's certain memory overhead associated with the basic interpreter running. I don't know what the exact number is supposed to be, but I remember that was always less than 16K. So this seems to be working. I'm going to go ahead and test the other power supply, and then when we come back, I will hook up the expansion interface. Next, I've removed the PCB from the expansion interface, and it's going to need some repairs and gluing together, but nothing that's the case, of course, but there's nothing that super glue can't handle. So brief overview of this. As said before, this will add you, or let you add up to 32K, and when I opened it up, it looked like it had 16K populated and the rest is empty. There's no jumpers or PALs or anything required for the memory upgrade. You just put in chips and the software will check them. Other things of note, of course, are regulators here to generate the 5 volts, minus 5 volts, and 12 volts that are required for the DRAMs. Here's a disk controller chip, bunch of nickel and dime logic. They do use a delay chip, an analog delay chip, to generate the RAS and RAS, CAS, and MUX signals for the DRAM refresh. It has like 3 cassette output ports, or cassette ports on the back, and a relay controlling them all. Not exactly sure why. I mean, I know it was a pain in the ass to do a single cassette player, but I guess this let you like copy them, or cassettes were not, analog cassettes just didn't work very well for data storage, and fortunately that got remedied by them coming out with the small disk drives, the 5¼ inch drives. And then we have a straight through 40-inch parallel connector that connects to the back of the computer and to the expansion interface. And this was always the Achilles heel of the setup, because the connectors tended to get dirty, and I mean, whenever something doesn't work, the first place to look at is this interconnect cable. And the interesting thing was, in the first revision of this, you can see they got two buffers here to take care of the signals coming in. The first revision didn't have these buffers, and the expansion interface has just always acted badly. So what they did was they came up with a buffered cable, they called it, which had a plastic pod in the middle here and actually contained these line drivers inside the cable. And that supposedly fixed the problem, but they quickly redesigned this board, put the buffers on the board itself, and went back to a straight interconnect cable. So one of the first things to do would be to measure, see if we have all the supply voltages here. And the best place for that is probably measuring the DRAM sockets. It's only fitting that we use a genuine Radio Shack meter to have a look and see what appears on the DRAM voltage buses. So looking at the data sheet here, pin 16 is VSS, which is ground. Well, we've just turned it on. This relay pulled in immediately, which is for the cassettes, and I have to check whether that's supposed to pull in or whether it's under computer control. But keep in mind there's no computer connected right now, so we don't know what's going on in here. But anyway, pin 16 is ground, and let's see, 5 volts is on VCC, which is pin 9. So we go to ground, and we have a good 5 volts. Next is the minus 5 volts, which is called VBB, and that's sitting on pin 1. That's also good. And last but not least, we have VDD, which is 12 volts, or supposed to be 12 volts. And there you go. Voltages are good. You can see I kind of put the power supplies back together again. The one with the screws was, of course, no problem. However, on the other one, the one that was glued, I temporarily put tape on it just in case the fuse blows or it acts up. I didn't really want to glue this back together just to find out that I had to break it open again. But let's go ahead now and hook up the expansion interface to the computer and see if the whole system works. So we're all plugged in, plugged back in. Monitor's still on. Expansion interface is off right now. You can see that I connected it to the computer via this 40-pin ribbon cable. I did clean the connectors on each end, and so this is on. Let's power up the computer. All right, what does that mean? Let's see. Well, it didn't see the expansion interface, it looks like. And that's because it's off. Now it's on, and we power cycle the computer again, and we get a screen of garbage. Now, it turns out that that's normal, because what it's trying to do, because of the disk controller on here, it's automatically going out and trying to boot off of a disk, which it can't do. So it just sits like this forever. And if you remember on the Model 3, it kind of did the same thing, except at least it cleared the screen, which it isn't doing here. But what you're supposed to do is hold down the brake key and then power it on. And we get the memory size. And then it goes into Never Never Land. Try that again. Nope. So with the expansion interface on, something's going bad. And what we did before is, I guess we powered it on without the expansion interface powered up, and then it comes back up. So something is happening on here that's preventing it that's preventing the computer from working. Let's look at this a little bit more deeply. I did a lot of poking around with this. My first suspicion was the interface cable, of course, and they've conveniently brought out all of the signals from the top of the connector are available, and most of the signals from the bottom are actually brought through to the top also. And when I started measuring things over here, I found several dead lines. Well, dead lines, they were not static. A lot of the address lines and data lines had some activity on them. Some data lines didn't, some address lines didn't. It was just very strange. I measured, there's a crystal over here, and that's because the main RAS signal for DRAM refresh comes from the computer through here, and then the CAS signal is derived from the clock, from the crystal over here. But this was running fine, and that wasn't the problem. So I suspected the interface cable, as I mentioned before. But then by pure happenstance, I found out that right after you power up the computer, all of the signals are live. And I basically went over to the DRAM, to the empty sockets, and saw that for roughly 5 to 6 seconds after power cycling the computer, all of the lines were good. There was data coming in, there was data coming out. Everything seemed fine. Now these are 16K by 1 chips. They all carry 1 bit, but it turns out that, and that was completely, that behavior repeated itself completely, in that when turning on the computer, everything seemed fine. The computer, the way it determines RAM is, of course, since there's no jumpers or any option settings here, it does a read-write to different banks on the RAM, and that's how it determines how much memory there is in here. What indicates that there's a problem with the RAM probably is that when the expansion interface is turned off, the computer works fine. The data bus, when this reads something, the data bus is fed from this board. So then I started suspecting something wrong with the data bus, but I checked all of the buffers here, and here for the address lines and the data lines. And again, in the first 5 seconds of power, everything, all IOs seem to be live, but then just go into a real screwed up state. Now, I remember from quite some time ago when I had a computer just like this. Believe it or not, just like this. The computer like this was my main PC at the time. I never really got into the Apple machines of the same era. I just, this was the one. I lived in a small town at the time. There were no computer stores, but there was a Radio Shack store. So this was accessible to me. And I remember that especially the Model 1s tended to display memory problems, in that some of the RAM chips would just up and die. And in the old days, the test for RAMs was, which I don't recommend, was basically put your fingers on the RAMs and see if any one of them displays an unusually high or no temperature. And once or twice the test worked because I burned the crap out of my finger touching one of these things. It hurt like hell, but at least I would find the bad RAM. So I'm not going to do the temperature test here, but I'm going to try replacing RAMs and see if that makes a difference. Alright, I'm back. Sorry it took me so long. Hope you didn't get too bored here. But anyway, Murphy struck. I had every imaginable RAM, DRAM chip I had 4s, I had 64s, 256s, 1 megs, but no 16s. I mean, this is a generic 4116, the kind that uses the 3 supply voltages, and of course I couldn't find any of them. So I was resigning myself to the fact that I was going to have to go to eBay and actually pay to buy 8 of these chips. I mean, they're not that expensive, but it's still kind of a ridiculous concept for someone who has many spare parts, but obviously not the right ones. And then it struck me all of a sudden that if you remember a few episodes ago, I repaired a Model 3, and in order to repair the TRS-80 Model 3, I needed a parts machine. It had keys missing and various little things missing that I couldn't buy on their own. I found a good deal, bought a Model 3 with a dead keyboard, dead drive, and various other problems, but that helped me get the other Model 3 up and running. And guess what? The Model 3 has 48K in it, and they're all 4116s. And on the parts machine actually will boot up into BASIC, and I can check that it sees 48K, and it did. So that means I have 3 sets of 16K by 1 chips that I can use to try to isolate which one of these chips is bad. And here's one set I pulled out. They even marked with the Radio Shack logo. So now we'll go ahead and start swapping chips. Alright, power's off on the expansion interface and computer. So here we go. Chip number 1. Can't find my wrist strap, so we'll just have to be careful and not shuffle our feet on the ground. Expansion interface on, computer on. Remember, we have to hit the brake key, get to the memory size, and the brake key bounced. Error. I mean, it looks a little bit different now than what it did before, but we didn't fix the problem. Off to the next chip. So I mean, if this works and we hit enter after the memory size, it should show us a number close to 32K. Next. How about that? Oh yes, of course, I haven't turned on the expansion interface. Okay, again. And it just goes into Never Never Land. One more try. Oh, this time we got a dollar sign up here. Anyway, problem still not fixed. Let's turn everything off again. No, I'm not a fan of fast forwarding this, because once you fast forward it, something really interesting happens. So again, using Murphy, I'm not going to fast forward it. Yeah, but that means nothing interesting is going to happen. Well, anyway, let's see. So, place the third one. And did I not? Yeah, I forgot to turn it on again. The expansion interface is on. Oh. Yes, it is on, and it came back. So, oh, did you see how badly the keyboard's bouncing? That's going to need to get cleaned, but so we should see something around 32K now, and we do. Well, looks like the expansion interface is working after all. Let me just go in and kind of go backwards. I mean, we changed this chip, so most likely this, whatever was in here, was the one that was bad. But I'm just going to go in off camera and put the old ones back in one by one and isolate the bad chip. Yes, it was the third chip. I replaced 1 and 2, and things are still working. Let's do this again with the bounce. Now it doesn't bounce anymore. All right. And 32K. So next what I'll do is I'm going to put 2 sets of identical RAM chips in both rows, which I'm going to cannibalize the parts Model 3 for, and see if we can see 48K coming up. So here you go, 2 banks of 16K identical RAMs out of the Model 3. I had to take these out. I really don't trust them. I almost forgot to mark the bad one. But, well, here's some spares, because I kind of suspect that inside of this, the computer, it's probably using these, the same, it's from the same era, so the 16K chips are probably like these. So if I ever need any, I got some more, and I got another bank of 16K in the Model 3, of course. So now let's see what we get. Expansion interface is on, brake key, power. There you go. So let's see who can guess what the exact number of free RAM will be when I print it out. Bouncy keyboard and syntax error. 48,333. All of the RAM is functional, because you saw that there was a bit of a delay after I hit the enter when the memory size thing came on, and that delay increases actually the more memory it's looking at. So it's not just like writing a single byte in there and reading it back. It's, I don't know what intervals it uses, what memory size it uses, but it does do a semi-thorough test on boot up. So this number, so when it does come up, it's usually a pretty good indication that the RAM is good. So there you have it, RAM works. And so the next thing to try is the disk drive. I don't really want to take apart my good Model 3 for another disk drive, but I do have a solution. And let me get set up and show you what I'm going to do. So for the disk, I'm going to use the HXC floppy disk emulator, and I have an image of an OS for the TRS-80. It's called New DOS 80. So first we power this guy up, and I don't know if you can see that, but basically I have the New DOS image selected on it, and stay. Expansion interface comes on, and this time we're not going to hit the brake key because there's a floppy here. And what do you say? It loaded. So let's see if we can get a directory. Seems to work. And so let's run something on here. disassemble. Object from main memory or disk. Let's do main memory. Object virtual base address. Object real base address. I don't know. It's the same. Any options? No. Okay, there you go. How do you stop this? Oh. Control C, where is it? Exit. Oh, there you go. Another disassembly. Sure, why not? Oh, this is a Z80, so it's actually booting from low memory. So let's have a look at low memory. And there you go. It's actually disassembling. So, looks like this guy's working. We get things up and running. I did try to load another few images from here, but they won't load because I'm not exactly sure whether the images are Model 1 or Model 3 specific, and sometimes I get a no system error, which means it's expecting the OS to be on the same disk, but they're not. So just for grins, I mean, if I select a file called Cavern Q, so it retracted the head to track 0, but it can't even read this stuff. So I'm going to have to do some more research to see which objects, which images actually load. But just to make sure that I didn't break anything, let's go back and load new DOS 80 again. And there you go, and we are still running. So run a spool, chain build, LM offset, super zap. Well, let's have a look at super zap. Oh, stop bouncing. There you go. Display track sector. Verified disk sectors. Sure. No. Drive and relative sector within drive numbers. Drive 0, 0, I don't know. Bad illegal drive number. Still a bad illegal drive number. Illegal or missing drive number. All right, I have no idea how to use this. I'd have to read up on it, but I guess it's doing something. Display main memory. It's not what I wanted. Ah, the minus key. goes back hex 100, thus the plus key should go forward, and it does. So we have the pleasure of looking at the memory contents. Anyway, it does seem to be working, but I think that's enough for this episode. Put the expansion interface back together. Things still working. One thing though that keeps bugging me is I can't figure out the parameters for Super Zap, but I think I did. So if we run Super Zap, and let's say we do display a track sector, so it wants the drive separated by a comma by the relative sector number. I think, well, it's a sector number starting from 0. So if we do that, boom, there you go. It shows us something. Some sort of directory or something, but it's obviously reading the disk. So things still work. We're in good shape. There are some open issues here, obviously, that I will not get to in this episode, but first of all, the expansion interface is going to need new caps. There's like a 10,000 microfarad and a 2200 in there that should be replaced. The monitor needs to be recapped. One thing I noticed is sometimes when you hit keys, the display shifts, and I can't see a wave going through it. It's very slight, but this needs a recap. And of course, most important of all, we haven't even looked inside of this guy. I mean, it works. Why fix it if it ain't broke? But I'm kind of curious to see what it looks like inside. The keyboard needs to be opened up and cleaned. It has these helper stickers on here, and I think what these indicate is they're like labeled word, line, paragraph, or page. Somebody was probably running a word processor on here, and what that means in turn is that this should have the hardware lowercase mod installed, and I want to see if that is in fact the case and find the drivers to activate it. And in addition to cleaning the keys, the key bounce, Radio Shack introduced a key debounce routine that also had to be loaded manually, so I'm going to have to track that down. So there's quite a few things left to be done with this, but we got it up and running. The expansion interface is put together. We know that the memory and the disk interface works, which brings us to I need to put a real disk drive on this and test that too. So we have a long laundry list of things that yet need to be done. The purpose for today is fulfilled because what we're looking at works. And I hope you enjoyed this episode. Please support the channel, thumb it up preferably, and subscribe if you haven't already. And we'll see you at the next episode.